Got a typical exam question here to calculate Kp. So here it is. Going to read through this, then if you want to pause the video, have a go, and then play when you're ready to hear the answer. So it says a chemist investigates the equilibrium shown below. So we've got that one there. So the chemist mixes together those many moles of methane and water in a sealed container. It's heated to a constant temperature, obviously high enough for the water to become steam, and allowed to reach equilibrium. And we're told the equilibrium mixture was found to contain that many moles of methane and that the total pressure was 30 atmospheres. And from all of that, we have to calculate Kp. And that question was worth 7 marks. So if you want to pause the video now, have a go, and then play on when you're ready for the answer. Okay, so there's the equation again, and my trusty ICE acronym. The I stands for initial moles, the C stands for the change in moles, and the E stands for equilibrium moles. So straight across the top, I'm writing the moles that we know about initially. So there was 1 mole of methane and 1.4 moles of water. And obviously there wouldn't be any hydrogen or carbon monoxide straight away. And we were told that at equilibrium, the methane was 0.2 moles. So there's been a change in methane, it's dropped by 0.8 moles. So now we know that, we can work out how much the others are going to change by. So the water, or the steam, is going to go down by the same amount because there's a 1-to-1 ratio there. The hydrogen is going to go up by 3 times that amount because there's a 1-to-3 ratio between methane and hydrogen. And the carbon monoxide will go up by 0.8 moles. So now we know that, we can work out the equilibrium moles. And so it's simply just 1.4 minus 0.8 and so on. So now we know the equilibrium moles. Good idea to work out the total moles because we need those to work out the mole fractions. So there they are there. The mole fractions are just the equilibrium moles divided by the total moles. So there's my calculations there. And then we use those mole fractions to work out the partial pressures. If you remember, the total pressure was 30 atmospheres. So the partial pressures are going to be the mole fraction multiplied by the total pressure. So you can see there they are there, 1.5, 4.5, 18 and 6 atmospheres. There's no need to change the units of pressure. It's not an ideal gas question, so atmospheres are fine. So now we'll bring in the Kp expression. So it's the partial pressures of the product over the partial pressures of the reactants. And remember that any balancing number becomes a power. So then we sub in our partial pressures that we've just calculated, and we get a numerical value for Kp of 5184. The units would be atmospheres to the power 4 because we've got atmospheres cubed times atmospheres on the top and atmospheres times atmospheres on the bottom, and then therefore they would cancel to atmospheres squared. And a top tip there, the exam question, I've typed it exactly as it was written on the paper. Notice they didn't say and state its units, they left that out, so don't forget to do that. There's always going to be a mark going for the units.